Objective 4, be able to write the dissociation equation for an acid or base in water. So I usually attempt to write these without including water because water is really just pulling the two ions apart on either an acid or a base. And you'll find if you do this, the only one you can't write without including water is a weak base when you have NH2 or NH3 involved. So HCl is just going to get pulled apart or dissociate into H+, and those ions will be aqueous, plus the Cl minus, and those ions will be aqueous. So it's not a bad thing to include your state symbols to understand what they are. NaOH will also get pulled apart by water, but now you'll have Na+, so the metal, and then you'll have the OH minus ion. Oh, I did it again. So again, my OH minus ion. And these will both be aqueous as well, so I'm just going to do a little cut and paste here. And then my CH3COOH, you should be able to recognize a weak acid that H plus is going to fall off. Oops, that's not quite what I meant. I just wanted to copy it. So it's going to leave behind the CH3COOH ion, which is now going to have a negative charge to it. Plus I'm going to have the H plus. And these, of course, will be aqueous also. So for these first three, you simply have the acid or base just being pulled apart into the two ions, into your cation, your anion, for the acid and base. So those are pretty straightforward. And then my weak base is slightly different because now if I try and pull it apart, there's not an H to take off here. The carbon hangs on to its hydrogen, the nitrogen hangs on to its hydrogen. So what actually happens here is the CH3NH2 takes a hydrogen from water. So I end up with CH3NH3, and that's going to give it a positive charge because it's taken the proton. And then that's going to leave behind an OH minus group, which is why this is a weak base, because it's generating OH minus in the solution.